start you off with an introduction to limits, because that's the first topic you're going to see in a Calc 1 class. Before we get into any of the fancy stuff in Calc 1, we have to talk about what's called a limit. And a limit asks you the question, where's your function going on a graph given a target value? So if we looked at, say, this graph. Let's say they ask, what is the limit of this function f of x as we approach the target value of x is equal to 1? The way we would write that is we do a fancy lim like this. Since we don't actually have like a formula for the function, we'll just use f of x. But if we did know what it was, if we knew like this was x squared plus 7, we'd put x squared plus 7 here. But since we don't know what it is, we're just going to label it f of x, saying it's just a function of x. And the target value we're looking at is that x approaches 1. But we say approaches, it's not equal to, because we're just saying where's it going. The only problem we have is we can approach this from the left side, coming down and over, or we can approach it from the right side. We come down, back up, down, over. So if we want to figure this out, we first need to figure out what's the left limit and what's the right limit. Because we can approach from two different ways, we need to see what happens when we approach from the left, what happens when we approach from the right. So if we talk about the left limit, everything is going to look the same, except to represent the left, we're going to put a little negative sign, because negatives are on the left side. So put a little negative right here to show it's going from the left. If you want to come from the right, since positives are on the right, we're going to show a little plus here. Right, so if this is 0, negatives are to the left, positives are to the right. So let's see, coming just from the left side, we can't see anyone here. We would come down and over, and the height or the y value that we land at is 1. So the value of the left limit is going to be 1. For the right side, we would come down, back up, down, over, and see how we land right here at the same spot. So this height or y value is also 1. So the left is 1, the right is 1. So the good news for us is if the left and the right are equal, then the limit does exist, and it's whatever those two people meet at. Since left is equal to right, this means it's good. We have a limit, and the limit of this person is going to be 1 because they meet at the same spot. So this person is equal to 1. And that would be how you do a limit. So let's go ahead and look at 2. So we looked at 2. Let's say they want us to figure out the limit of f of x as x approaches 2. So what we should do is find the left limit, find the right limit, and if they match, whatever that match is going to be the value for the limit. So without doing it out left and right, let's see what happens. So from the left, we go down and across, and at 2, we're going to stop here. So we have a height of 1 or a y value of 1. From the right side, we're going to come down, back up, come down, and see how this person also stopping at a height of 1 or a y value of 1. So since they meet the same spot, this person is going to have a value of 1. Because we checked the left was 1, the right was 1. So then the overall limit is going to be 1 for as x approaches 2. But as long as the lines are meeting at the same y value, we're going to have a limit. So as long as the train tracks are meeting at the same spot, we're going to have a limit at that x value. But let's look at this person, because something funky is happening here. So if we look at this, from the left side, we approach 2, right? So from the left side, we can't see this. So we have a y value of 2. From the right side, we can't see this. So we come down here, and we have a y value of 1. Well, there's like a jump. Like the train tracks aren't meeting. So these trains can't get to the same spot. So since there's a jump, that means there's no limit for x is equal to 3. So we'd say that the limit for our function as x approaches 3, we'd say is no limit or does not exist. But if we want to prove it, just so we can see, we would basically say what's the left, what is the right, and then do these two people match up. So looking at the left, right, we said that from the left side, we stopped at 2. From the right side, we stopped at 1. So since these two are not equal, we can't have a limit there. And that's how you visually can check for a limit of a function. So you check left and right are the same. If they are, you have a limit. If these two do not match up, then you do not have a limit at that